Well, greetings. Welcome to your first year experience at Trinity University Climate Change. My name is David Ribble. I'm a biologist at Trinity, and I look forward to teaching one of the sections. And I want to take this opportunity with this little small video to give you some basics of climate change. So when you show up on campus, you can hit the ground running. So this iconic picture and iconic music is pretty classic. But when we look outside during the day, you see up through it looks like a vast blue sky, but in reality, it's not, in the sense that there's a thin shell that surrounds our atmosphere, and that thin shell, the two uppermost layers, the troposphere and the stratosphere, are really, really important in maintaining life on this planet. And it's also really relevant to climate change and what's going on with climate change. So let's look at that. So of course, solar radiation hits the Earth in the form of light waves, and it passes through that atmosphere. And most of this radiation is absorbed by the Earth, and that's a good thing. Some of that energy is radiated back into the space in the form of of heat waves, but some of it is, of course, trapped. And it's trapped in the atmosphere primarily by carbon dioxide, which you're going to hear a lot about this semester. So carbon dioxide is a gas that's trapped in the atmosphere, and it's able to absorb that heat and retain that heat. And that's what's causing essentially the warming of our climate. Now, it's called a greenhouse gas. The effect of what I just described is not exactly analogous to a greenhouse, but that is stuck, so we will use that. So you're going to be hearing a lot this semester about carbon dioxide and carbon. So recall that I'm a biologist, and so one of the things that I'm interested in you understanding is the carbon cycle, because the cycling of carbon has been going on as long as basically we've had photosynthesis on this planet. And so let's take a look at that. What you see here is what I call the fundamental biochemical processes on this planet, okay? And the first process is photosynthesis. And photosynthesis is the process that we see in autotrophs, which autotrophs are organisms that manufacture their own organic materials from inorganic sources, in other words, plants. So I think you've been exposed to photosynthesis. It captures carbon dioxide, and then with water and light, and then in the presence of chlorophyll, the results of this are the production of oxygen. That's a good thing. We need that. And these 6 carbon molecules, which are basically the sugars, which go into all sorts of plants that are important, plus water. Now, heterotrophs then take advantage of this. We're heterotrophs. We require energy-rich materials. And we take those sugar molecules in the presence of oxygen, and then that biochemical reaction provides us energy. So these two biochemical reactions are really critical to our life on this planet. And this sets up, if you follow the carbon, what is known as the carbon cycle. So what I just showed you is photosynthesis that results in the release of oxygen. It produces energy storing molecules. That then is stored in so-called biomass. Here we show a big tree. It could be plants. It could be moss. It could be all sorts of things. And then as these do their thing, plants do respire. They release carbon dioxide, and also when they decay. And then that is carbon dioxide then that can continue that cycle. So that's a very simplistic matter. If we look at the global carbon cycle, which is shown here, these are numbers that show the approximate gigatons. That's a lot, gigatons that are produced. And so if we follow carbon, we see that on average, what we have is that 6.3 gigatons are released, 1.6 gigatons are released into the atmosphere. These are older data during the 90s, into the atmosphere. What's interesting is to compare, so these are released by cutting carbon in the trees. These are released by fossil fuel use. But then that carbon is taken up by photosynthesis and chemical processes in the ocean, as well as net photosynthesis by plants. Okay, now you don't need to be a rocket scientist to see we're producing 6.3 gigatons here, 1.6 here, this is per year, and we're only taking back 3 and 1.5. So in other words, there's a net flow of carbon into the atmosphere, and that's been going on for quite some time. Well, let's look at it another way. So carbon is always, like I said, been a cycle. Things recycle around. So there's carbon dioxide in the air that plants take in. They produce biomass, sugars, things that we like to eat, so forth. That can be eaten by heterotrophs and respired. It can also turn into rotting plants that return the carbon to the soil, and then decomposers feed on these dead plants and release that carbon dioxide back into the air to complete this cycle. Now, what is in effect changing this cycle is the fact that we are now, in the modern industrial world, taking captured carbon in the form of fossil fuels and releasing that. So that's releasing more carbon dioxide than can possibly be taken in. And so that's why we have created this dilemma that we are looking at. So there's this is a complex figure that shows all sorts of ways in which carbon is released into the environment. But it's important to know that the main source and cause of the rising global temperatures that we're seeing today is the burning of fossil fuels. So fossil fuels, where did they get there, and why are they important? I found this video interesting, so let's take a look at this.
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans, and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are 3 major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
And the question is our temperatures getting hotter? Absolutely they are. There's no doubt about that. And this is linked to this extraordinary consumption of fossil fuels that's releasing that carbon dioxide. So I'm going to stop there, and hopefully this helps us prime ourselves to be thinking about the science, but during the term we're going to be thinking about all sorts of issues related to climate change, from an artistic, from a poetry, from science fiction, and so forth. And we really look forward to seeing you on campus and engaging you with this topic. So travel safely. We'll see you soon.